Okay, this will be unit 1. This will be the calculator part of the review now. Okay, determine whether this is continuous at x is equal to -7. If it's discontinuous, identify the type of continuity. Okay, all right. Well, if we can figure out whether it's discontinuous, okay, all right. Well, what I got here is if I factor that top, I got x plus x minus, and this is x plus 4. Now what happens is that x plus 4 goes away. Okay, now if I solve that, that would be x equals -4. That's a removable. Okay, so then what I have left over is this. So I have a removable at x equals -4. So it's obviously discontinuous. Okay, all right, now, these ones with the piecewise have a potential to be a jump. Okay, now, how do we know that? Well, the piecewise sometimes will jump, sometimes they will not. Now, here's how I figure that out. I take 1, which is the point in question here, and I'm going to substitute that into, okay, I'm going to substitute that into both problems. Okay, well, 1 squared is 1, that would be 2. So this result here is 2. If I do this one though, this is -1 plus 2, which would be 1. So what I have here, because these values are different, is I have the jump. Okay, and if you were to plot that out, that's how you could see it. Okay, so this is discontinuous. Okay, all right, but you have a jump there. Okay, if those numbers were the same, it would have been a continuous function. Okay, it would have been a continuous function. All right, determine whether this is continuous at x equals 3, x equals 0, x equals -2. Okay, all right. All right, so what I want to do, okay, is look at, if I took out this would be x minus 3. If I took out an x there, that would be x, then it would be x squared minus x minus 6. Now that would factor to, on the bottom, x minus 3, and x plus 2, okay? So what I have here is this. So this x and x get eliminated. Okay, that's x equals 0. This x minus 3, if I solve that, that's x equals 3. These are both removable. Okay, now what's left over is x plus 2. So if I solve that, that's going to be x equals -2, and that is an infinite discontinuity because it is an asymptote. Okay, all right, so that's your answer for that one.
Ms. Flores, can you come to security, please?
Okay, question number 25. Determine whether this is continuous using all 3 parts, all right, of the continuity test. Okay, now this is where the calculator really comes into play. Okay, what I like to do with that, okay, I'm going to put that function into the calculator, all right, and I'm going to do that in the table feature. It just makes this easier. I'm going to do 2x squared minus 5x, all right, minus 6. Table. All right, now they're asking, is it continuous at 2? So I'm going to type in 2. I get a result of -8. So at f of 2, I get a result of -8. Now, what I want to do is I want to make a table around 2. Okay, so here's 2. I'm going to do 3 numbers above and 3 numbers below. So 2.1, 2.01, 2.001. Okay, and I want to see what those results would be. Okay, all right. Then I'm going to go smaller, 1.999, 1.99, and 1.9. All right, so I know this is at -8. Okay, so what I want to do, pretty simply, is just type these in and see the results. So at 2.1, I get -7.68. Okay, 2.01, I get -7.9. Oh, whoops, I did that backwards. Sorry, hold on. I made my table a little bit backwards. Hold on. Got a little ahead of myself there. Okay, 2.001, 2.01, 2.1. So that first one, was, I got negative, 0.796. 2.1 was negative 7.68. Sorry about that. And then 2.001 is negative 7.99. Okay. Now let's go the other way. 1.99. Okay. 1.99. 3 nines is negative 8.02. Then I got 1.99 is negative 8.02. And then negative 1.9, or 1.9, sorry, is 8.28. Okay, now as you can see, both of these are approaching, okay? So this is good. So the limit as x approaches 2 equals what f of 2 was, okay? And so that's why this is continuous, okay? And I do the same thing for this problem here. All right, so now new function. I got negative 4x cubed plus x squared minus 2. Okay, all right, so what I want to do is evaluate that at negative 1. So I get a result. So f of negative 1 gives me 3. So now I want to make this table. So I'm going to be at negative 0.999, negative 0.99, and negative 0.9. I'm going to be at negative 1.001, negative 1.01, and negative 1.1. Okay? And I'm going to look at all these values. So let's start with negative 1.1. Oops, calculator sometimes is not great on the board. I got 4.5 basically. Okay, then negative 1.01 is 3.4, and then negative 1.001 is negative 3.01. We already know that this is 3. Sorry, 3. Okay, all right. Then I'm going to do negative 0.939. That's 2.986, which is what we wanted to see. And then I just do this a couple more times for negative 0.99, 2.86, and then 0.9, or negative 0.9. It is 1.7. Okay? Now, as you see, as they come from both directions, they're both getting closer to 3. So that's good. So the limit as x equals approaches negative 1 equals the same thing as f of negative 1. So it's continuous. Okay? And I think that's it. Okay, that's your unit review for this unit.